Thank you very much. This is an amazing event. I'm last, and I'm very thirsty. I'm sure everybody's very thirsty, so I'm going to try and be really snappy, but I do need to warm up a little bit. Who loves Passivhaus? I love Passivhaus. So I was recently trying to think about, how do you start a talk like this in front of this is a pretty serious crowd. This is a bit intimidating. I'm used to talking in front of architects, and that's easy. I think people here know what they're talking about. So the point being, that's funny. So the latest national survey of energy use, commercial and institutional, done by EnerPHit, registers the average energy use intensity for commercial buildings as, does anybody know the answer to this? There's a beer in it for you. 335 kilowatt hours per square meter per year. That's the average. 4 years ago when they did the survey, it was 350. I'm going by memory here, but I like these numbers. Well, I don't like those numbers, but I like to remember them because what's the thermal energy demand intensity for Passivhaus? 15. That's amazing. We can do it. I just think we need to educate ourselves and push forward, and it's a lot of fun. And venues like this, it's amazing what I've learned already. It's I'm taking notes back there. It was awesome. Thank you, Andrew, and the previous presentation was great. So, Humber College, Building Nx. Humber College is a great client. I've done 4 projects for them, and they're super interested in reducing their carbon footprint. So they're taking their older buildings and saying, what can we do to improve their performance? And they're looking at Passivhaus. And they said, can we do it? And I said, let's try. And we're doing it. So we're taking this is used to be the North Campus Library building. It's now an admin and student center. And this is the before. And maybe you can't quite tell, but the majority of the enclosure system is, and this is all I have to say, I think, glass block. I mean, that's pretty high performance. Wow. So I didn't have to do too much. I'm starting with the solution. So we had 3 months. Because we know Humber so well and done 3 projects with them before, we weren't super concerned about some of the challenges that they asked us to. I mean, it's just, it can be fun with the right group. So 3 months, can you propose? They'd gotten access to some funding for greenhouse gas reduction, so to the tune of about $12 million. And so they wanted to dedicate about $8 million to this project. So we did a full reclad and a full systems retrofit. So part of the problem was to, and this is always a challenge and also an opportunity, but we had to do it fast. And so we said, how can we do this with conventional technology, use conventional trades? So a very simple system of light steel backup with rain screen cladding systems, composite aluminum, and corrugated painted steel to meet our budget restrictions, and then super high performance Passivhaus certified windows. You're right, it was too light, I'm sorry. So I just wanted to quickly talk about, as we started, I should just give a shout out to my colleagues at B+H Architects, worked with an amazing crew to draw up the project. Our engineers at Morrison Hirschfield were also amazing and very collaborative. And we also worked with RDH to do a supplementary hourly simulation to try and test out some of our scenarios. So what we really focused on was the, and I think everybody here believes this, it's the connection between systems. We can develop fairly accurate models of field values, but when we connect systems to systems, we really have to understand how the heat flows. So we really focused on our connection of our systems. So one of the things I wanted to talk a little bit about here, and I know that this is, I feel I'm of 2 minds of this, but nonetheless, we used a bunch of foam in our project, and we actually got factory cut rigid foam to help us insulate our window frames. And that actually worked out really well with the trades on site. Further head details, connection details. We really reinforced engineering transition details to help us maintain our airflow between assemblies. And then an existing building always comes up with these nasty transitions that we have to work through. As we design buildings that perform better and better, the small holes become a bigger part of our problem. So we ended up focusing on these transition details very, very heavily. These are the elevations. This is just to show you that one of the things we learned here, this is about 25% window to wall ratio. And the point of this slide is actually to indicate that as we race through the project, having lots of fun designing, our effective thermal performance for the opaque assemblies was about R43. And we used Passivhaus certified windows, a Schuko product. We started to realize as we were running our energy simulations, we were actually overheating in the building. So this is about 55,000 square foot building, and the core was starting to overheat. So we realized that actually we were maybe being a tad stingy on the windows. So in retrospect, we might actually let a little more heat flow out of the building. On the energy use side, we ended up in and around the 64 kilowatt hour per square meter energy use intensity, which is pretty good for an institutional building. This is the first retrofit institutional building in North America for Passivhaus. We use the EnerPHit standard. And we can just start seeing, this slide starts to indicate how, as designers, we start controlling our base building loads, but the lighting and plug loads become such a huge part of the puzzle, and that's something that we don't have a huge control over. So we worked with Humber to look at a lot of their existing buildings to really get more accurate information on how people actually used plug loads and process loads, because we tend to overprogram our plug loads. So the problem is the engineers start designing for a cooling load that doesn't exist. So I know you can't read this very well, but it's just a backdrop. The idea here is on the mechanical side, we used a decentralized VRF heat pump system, air source. And what was good about that was that we could use the refrigerant loops, the heat recovery, the internal heat recovery, move the heat from the core to the perimeter. And that was a VRF gives us that great opportunity. We used the Swegon dedicated outdoor air ventilation system, demand operated. So we separated our heating and cooling from our ventilation. Of course, all good designers do that. I feel like I don't have to say that here, but I have a tendency to say that a lot. The building being existing, there was a lot of infrastructure that already existed in the building, so we just augmented that. So on the lighting side, we're down at about a little less than 4 watts a meter for our lighting density, and that's primarily through controls. I don't really know what these controls are, but they look fancy. Now, the building, we designed a 25 kilowatt PV array for the roof, and the building is also achieving the Canadian Green Building Council zero carbon certification, so that's also great. So yeah, it's good for them. Yeah, Passivhaus and zero carbon. These are just a few images of the project. We hope it looks okay. I just wanted to maybe talk a little bit about some of the lessons learned. So we started working with structural plastic to try and reduce our conductors through penetrations. We found that very, very effective. So I think this is becoming more available and less costly in the market. So as we start getting better at detailing, we can start using some of these innovative technologies to, if there ever are penetrations, we can really reduce our thermal conductance. And that's it. Thank you very much. Am I on time? Is that too fast? Oh, 10 minutes? Oh, no, no, this is the time for questions now. I planned that out. Question time. Any questions?